Now, let's look at the OSI or Open System Interconnection Mode or framework, which is used to help understand how different parts of a computer network work together. It's like a roadmap for how different parts of a computer network work together. Starting at the top, we have layer 7. We'll be counting down as we go along. So layer 7 is the application layer. Layer 6 is the presentation layer. Layer 5 is the session layer. Layer 4 is the transport layer. Layer 3 is the network layer. Layer 2 is the data link layer. Layer 1, finally, is the physical layer. So you move down layers when sending data, and you move up layers when receiving data. The application layer is where you, the user, interact with a computer application that sent a data request. So if you're receiving data, this is where the application shows you the request. The presentation layer is where data is reformatted through encryption and compression when sending data, or decrypting and decompressing data when receiving data. It's like a translator that helps different devices understand each other. The session layer is where session IDs or cookies are created so the communication devices remember each other. If you're receiving data, this is where the session ID is received and used each time data is sent. It's like a secret passcode between devices that let them know they're still talking to the right person in a conversation. The transport layer is where data is broken down into segments when sending data and reassembled when receiving data. This layer is like the traffic controller of the network, making sure data flows smoothly. The network layer turns data segments into network IP packets, so routers can find the best routes to send the data IP packets. It's like a GPS for data packets. The data link layer turns network IP packets into frames, so when the frame reaches a device, the device knows where to send the data next. It's like a courier delivering a package. Finally, we have the physical layer where frames are turned into light signals to go through fiber cables. Electrical signals go through Ethernet and coax cables, or wireless signals for Wi-Fi connections. It's like the delivery truck that gets the ones and zeros that make up the data to the next device. I've got a little trick to help you remember the layers of the OSI model. All people send terrible nudes during Passover. I'm not sure if this mnemonic is politically correct, but it's definitely a memorable way to remember the different layers of the OSI model. Just remember that as an intertech warrior, we know it's always important to be respectful and considerate when communicating with others. So we've learned about the OSI model, which is made up of 7 layers: application, presentation, session, transport, network, data link, and physical. All people send terrible nudes during Passover. These are the 7 layers of the OSI model. Now let's see how the TCP/IP stack model compares. So this is what the TCP/IP stack model looks like. Okay, so the TCP/IP stack model is a bit different. Layers 7 and 6 and 5 of the OSI model, which all deal with communication at the computer level, are combined into one application layer. The network layer of the OSI model becomes the internet layer in the TCP/IP model, and the data link and physical layers of the OSI model are combined into network access interface layer in the TCP/IP model. So just going back. So this is the transmission control protocol internet protocol model, or TCP/IP model for short. It's a simpler way of organizing and understanding how communication works from computers to the internet and back. Let's take a look at just what protocols and PDUs are, since these two concepts will come up a lot in IT. A protocol is a set of rules that determines how data is formatted. This helps different systems and applications understand how to read and send data. A PDU, or protocol data unit, is a single piece of information that is sent from one computer or device to another. So to create a PDU, you need both protocol data and user data. Protocol data tells you how the data is formatted. User data, on the other hand, is the actual request or answer from a user, web server, or application. So when you put these two elements together, you get a protocol data unit, or PDU. Here's a little inner tech warrior PDU character to help you visualize it. So there you have it, a brief explanation of protocols and PDUs in IT. Keep these concepts in mind as we delve deeper into the world of computer networking. Now we're going to take a look at the tops of the application protocols and ports. Just like ships have designated numbers to help you know which port to dock at, data has designated port numbers to help it know which application service to go to. Here's an example of a TCP port number on a sending and receiving end. This was taken from the netstat-a command on the Windows command prompt, which lets users see our current network connections. The TCP here lets you know that this is a transmission control protocol. This number next to the IP address is the source port number of the connection. Meanwhile, this HTTPS next to the destination IP tells us the destination port number, the port we're trying to make a connection to on the other end of the network. You could also think of these ports like addresses on a letter. Let's look at the example above and address the letter as if we are the sending device. The source port would go at the top left as that's the port we're sending from. The destination port will go in the middle of the letter, and in this case, we know that HTTPS is normally assigned to port 443, so we know that the destination port address here is 443. And then this data packet would be sent out and placed at the destination port, just like being delivered to a mailbox. Here we're going to learn about some common applications that have specific ports assigned to them. This is useful information to have when you're trying to troubleshoot or understand what's happening on a network. Knowing which ports different applications use can help you identify what may be causing issues or what kind of traffic you're looking at. I'll also give brief overviews of each protocol, but you don't have to memorize any of it. Just keep in mind how these protocols are used. So first we have DNS, which stands for Domain Name System or Domain Name Service. It's used to convert IP addresses, which are like phone numbers for devices on the internet, into URLs that are easier for humans to read and remember. It listens on port 53 for requests from other devices. DNS servers listen on port 53 for requests from other devices to convert the IP addresses into URLs or vice versa. This way, humans can use URLs to access websites, but the devices on the network can still use the numerical IP addresses to communicate with each other. Next up is DHCP, which stands for Dynamic Host Configuration Protocol. It's used to assign IP addresses to devices on a network, kind of like how a phone company assigns phone numbers to phones. It uses port 67 and 68 to communicate. So DHCP servers listen to port 67 for requests for an IP address from a client device, like a laptop. They then use the same port to send the IP address lease information back to the client. The client device uses port 68 to listen for the DHCP server's responses and to send data back to the server. HTTP, or Hypertext Transfer Protocol, is used to transfer data between web servers and web browsers. It's the less secure, unencrypted way of sending data back and forth. Web servers listen on port 80 for data requests from web browsers on user devices. HTTPS, or Hypertext Transfer Protocol, secure, is the more secure, encrypted way of sending data between web servers and web browsers. Web servers listen on port 443 for data requests from web browsers on user devices. SSH, or secure shell, is used to create secure, encrypted connections between devices and over insecure networks like the internet. It's often used by system and network administrators, you guys, to manage and configure servers and network devices, as well as to transfer files. It uses port 22. SMTP, or Simple Mail Transfer Protocol, is used to send email messages back and forth between servers. When you send an email from your phone or computer, it goes to a server that stores lots of emails. That server uses SMTP to send the email to another server, which might be the server for the person you're sending the email to. That second server uses SMTP to deliver the email to the person's phone or computer. Port 25 is the main port used by servers to send emails to each other, while port 587 is used for encrypted secure connection and is used by people like you and me to send emails to the servers. FTP, or File Transfer Protocol, is used to send files back and forth between computers. Port 21 is the main port used by the client or the computer you're sending from to communicate with the server or the computer you're sending files to. Port 20 is then used by the client and server to actually do the data transfer. SFTP, or Secure Shell File Transfer Protocol, is a secure version of FTP that uses an SSH connection to encrypt the data being transferred. Because it uses an SSH connection, SFTP only needs port 22. NTP protocol stands for Network Time Protocol. It's used to synchronize the clocks on different devices on a network, kind of like how we set our phones and clocks to the same time, so we're all on the same schedule. NTP works by having a group of servers that are considered to have very accurate clocks, and these servers are called reference clocks. Other devices on a network, like your phone or computer, can then connect to an NTP server and ask it what time it is. The NTP server sends back the time, and a device can then adjust its own clock to match the time on the NTP server. Just going back up for a second, this way all devices on a network can have their clock set to the same time and make sure it's accurate. This is important for lots of different things, like making sure that the timestamps on your emails or logs are accurate, or for coordinating events between different devices. NTP uses port 123 to communicate. So if you see traffic on port 123, it could be devices on your network trying to synchronize their clocks using NTP. Next, we have SNMP, which stands for Simple Network Management Protocol. It's a protocol that's used to manage and monitor devices on a network. So an SNMP server manager, which is a central device that collects and stores data about the other devices on a network, listens on port 162 for the SNMP agents that are placed on devices on a network. So for example, if you wanted to check the status of a network device like a router that has an SNMP agent, you could use SNMP to send a request to the SNMP server. Then the SNMP server would then use port 162 to send the information back to you. So SNMP is designated port 161 for the SNMP agents on devices to send their data to the SNMP server. Kerberos is a network authentication protocol that's used to securely identify users and devices on a network. Kerberos uses a central server called the Key Distribution Center, KDC, which utilizes port 88 to allow clients, which can be users or devices, to authenticate. So the Kerberos server gives the client a ticket to prove who they are to other systems on the same network without having to share their username and password each time they try to use a resource. LDAP stands for Lightweight Directory Access Protocol. An LDAP server or directory, like Active Directory, which you may hear a lot, contains and manages information like users, their emails, and what they're allowed to access on a network, like servers or shared network folders. LDAP listens on port 389 for directory search requests from clients, which are users or computers. Radius, or Remote Authentication Dial-In User Service, is a protocol that's used to authenticate users and devices on a network. The Radius server listens on port 18 or 1812, 1812, 1812 for requests from authenticating users or devices. And the Radius server uses port 1813 to send data back, granting access to the user or device. So Radius servers can also use port 1813 to send data and statistics about the user's session to an accounting server to track the employee's data usage. TFTP, or Trivial File Transfer Protocol, is used to transfer files between devices on a network. So TFTP listens on port 69 for initial connection and then the transfer of configuration files, firmware images, or device images. So this would be something like if you were to upload a new device image to a switch or a router. FTPS, or FTP secure, is slightly different than SFTP. So FTPS is a secure encrypted version of FTP, but FTPS utilizes SSL TLS encryption instead of SSH, and it has 2 ports. So FTPS uses port 989 for the control channel. So this is the channel that's sending and receiving commands. And port 990 is used for the FTP channel, which is used to actually transfer the data between the client and the server. Telnet is a protocol used to remote into control servers and other network devices, similar to SSH. So Telnet is not secure and encrypted like SSH is, though. Port 23 is used by the Telnet protocol to create virtual terminal, which is like that black command screen, connections to devices. Telnet has essentially been replaced by the more secure SSH, which does basically the same thing.